Hello guys, welcome to the channel with GR of Talents. So we have been starting with the 10th class syllabus also from now on. So the first chapter of science that we have in class 10 is chemical reactions and equations. So let's get started with this chapter. Introduction to chemical reactions and equations. So basically there are two types of changes that you might have been knowing. Number one is physical changes. Number two is chemical changes. So if we are asked to give out an example of each of them, for physical examples, I remember the folding of paper that we use to do awesome origami. And for chemical changes, I remember the bonfire that we have set up when we went for trekking. So physical changes example would be folding of paper, and chemical changes example would be burning of wood. So if we are asked to define what is chemical change, then we can say it as one or more new substances with new physical and chemical properties. If you want to prove that this is actually true in our daily life situation, again let's take the example of the burning of wood. So for burning of wood, first we have collected some wood from around and then we have started burning it with the help of matchsticks or started using any fuel. So first, wood plus the oxygen that is present around us was also used for burning of wood. Basically, the cellulose is being burnt inside the wood. So cellulose plus oxygen. That is, on the left side, we have cellulose and oxygen, which are reactants of this chemical change or reaction. Then, after being heated, we have got the ashes that were remained, and we have also got heat energy and light energy and also carbon dioxide which is released. So we started with the cellulose and oxygen, but we got many more substances which are totally different from the beginning reactants, which are known as products. So this statement is quietly proved very easily. That is, we got many other different substances which we started with were different and which we ended up with different. That is what the statement said. That is, one or more new substances with new physical and chemical properties. All of them had new physical as well as the chemical properties. So that is nothing but a chemical change. And if you have to get more good at it, let's look at another example of this chemical change. We have Fe plus CuSO4 tends to, means after reaction what are being formed is FeSO4 plus Cu. Here Fe and CuSO4 are the reactants and FeSO4 plus Cu are the products being formed after the reaction is completed. You might be wondering what are the small letters in the brackets beside the actual formulas. S represents solid, Aq represents the aqueous, means that molecule is actually aqueous, and again FeSO4 is aqueous and Cu is again solid. So these are being formed. The things inside the bracket tell us actually the state of that material. Here Fe stands for iron and CuSO4 stands for copper sulfate. So after being reacted, we got the two new substances, that is ferrous sulfate and copper. Here also, as you can see, the entire substances were being changed physically and chemically. And we have also seen the color change here. That is, this solution before Fes plus CuSO4 was in the color of blue. But after the reaction, if you observe, it has turned into green color solution. So if we have to do it actually practically, we could do it something like this. We could just immerse an iron nail into CuSO4 solution, that is copper sulfate solution, and leave it aside for some time. Then you can find the copper deposits on the iron nail, and the solution also changes into FeSO4 solution, and the color also changed, as you can see from before. Before it was blue and then it has changed into green color. Now let's look at the physical change. We can define physical change as change in color or state occurs but no new substances are being formed over here. So again the same, let's take the example of paper folding of that origami that we have been doing. Here also, as you can see, no new chemical properties have been changed and no new substances with different chemical properties have been formed. There is only physical changes. That is, in this particular example of paper folding, we have been seeing the change in the state. That is, just the paper is folding and changing itself, means only the folds are being moved from one part of the other from the paper, but there is no actual change of the constituents of the chemicals that are present to make the paper. So there is nothing changed in the chemical properties or any proportions. This is known as a physical change. Here also, let's try to take one more example. Let's see what happens if you boil water. As you know, water will change to steam or otherwise called water vapor when it is being heated. Here also, there is new substances formed. Even though the steam and water look different when they are made to react with a piece of sodium, they react the same way to give the exact same products. So this involves only a change in the state. That is, it is being changed from liquid to vapor. If you are more interested about physical and chemical changes, I have dropped a link in the description box. You can check out more information about these right now. Okay, so now let's see what is a chemical reaction. We can define chemical reaction as chemical changes in which reactants transform into products by making or breaking of bonds between different atoms. It is as simple as that. So one of the example of this is that, as we have seen before, FeS plus CuSO4 tends to FeSO4 plus Cu is one of the quick chemical reaction. So now, as you have defined the chemical reaction, now you might be wondering, how do you find a chemical reactions? Just defining a chemical reaction would be worthless and useless without knowing how to find a chemical reaction. So let's see how to find a chemical reaction. The observations that help us determine a chemical reaction are as follows. Number 1, evolution of gas. If you pour some chemical in other chemical, if there is evolution of gas, you might detect and you might actually say that it is a chemical reaction. It is one of the sign or symptom of a chemical reaction. Next comes the change in temperature. If you see, is there any rise in the temperature, or if the temperature is lowered down as you are mixing any two chemicals, then you can define it as chemical reaction. And then formation of a precipitate. If you pour any two substances, if you see any solid particles or any precipitates that have been forming the below of the test tube, then you can say it's a chemical reaction. If there is any change of color, then also it might be a chemical reaction. It might also be a chemical reaction, sign of a chemical reaction. And then if there is change of a state, as we have been seen before, that is, if it changes from solid to liquid or liquid to gas or vice versa, then also we can say that there is some reaction, there is some chemical reactions in the substances. Okay, so now let's try to get deeper into chemical reactions and equations, as we have got the basics right. The word equation. A word equation is a chemical reaction expressed in words rather than chemical formulas. It helps identify the reactants and products in a chemical reaction. For example, we can take sodium plus chloride tends to sodium chloride. So the above equation means sodium reacts with chlorine to form the sodium chloride. Okay, now let's see what are the different types of chemical reactions that we can find. Types of chemical reactions: combination reaction, decomposition reaction, single displacement reaction, double displacement reaction, redox reaction, endothermic reaction, exothermic reaction, precipitation reaction, neutralization reaction. So these are some of the types of reactions that we have in this standard. We'll be looking at each of them deeply very soon. To know about chemical reactions and equations, we need to first of all know about the symbols of elements and their valencies. So let's start with the basics. So first of all, we can define a symbol as the chemical code for an element. Each element has 1 or 2 letter atomic symbol, which is nothing but the abbreviated form of its name. It is nothing but the short form. So we can just simply say that the element has a pet name or a short name which is used for naming it easily or saying it in general purpose. For example, many of your friends and your relatives might be calling you with your pet name in your house. But whereas if you stay in your school, you will be called with your official name. So the official name would be the original name of the element, whereas we use symbols for making it shorter and easier to write and represent too. For example, if we take the element of magnesium, it's Magnesium. It's that long, but it can just be written very shortly as capital M and small g. So while writing symbols, we must be very careful of the capital letters and small letters as it is case sensitive. We should look what the element is giving and what it is showing to know the symbol and write it particularly. So we are going to write the longer ones into short forms, that is known as the symbol of an element. Okay, so now let's see about the valency. Valency is basically the combining capacity of an element. It can be considered as the number of electrons lost, gained, or shared by an atom when it combines with another atom to form a molecule. As you might be knowing, an atom needs to lose or gain or otherwise share its particular electrons with any other atom in order to stay active or alive and to form a molecule itself. So valency is just the combining capacity of a particular element. It is as simple as that. Okay, so now let's move on. And now let's see how do we write a chemical equation. Representation of a chemical reaction in terms of symbols and chemical formula of the reactants and products is known as a chemical equation. So usually the chemical equations are represented in the form of symbols. We can also represent it in the form of words, but it is little difficult to write and we are a little lazy. So we'll write it in the short form. For example, we can take this Zn in the bracket S dilute H2SO4 in the bracket AQ turns to ZnSO4 again AQ plus H2, the arrow upwards. So now you might be wondering what are the things in the bracket. I've said you in the beginning of the video itself about these. Do you remember it? I'm going to revise once more. Okay, now look. For solids, the symbol is written in brackets S. For liquids, it is L. For gases, it is small g. For aqueous solutions, it is AQ. For gas produced in the reaction, it is represented by an up arrow. For precipitate formed in the reaction, it is represented by down arrow. And if we take the example that we have taken right before, Zn. So Zn in the bracket S represents that Zn is in the form of solid. And dilute H2SO4 in the bracket AQ represents that it's an aqueous solution. Then in the product side, we have ZnSO4, which is aqueous again, and H2 as the gas formed and which is being released from the reaction. So we try to get as much knowledge of the reaction as possible from the very small equation with the help of all this information. So if you are interested and you want to know more about chemical equations, the link is in the description. You can find it and know more about these chemical equations. Okay, alright. So now we have come to the most interesting and the difficult part too, that is the balancing of a chemical reaction. To know how we balance a chemical reactions, first we need to know some more important things. We should be knowing about the conservation of mass in the first point. So according to the law of conservation of mass, no atoms can be created or destroyed in a chemical reaction. So the number of atoms for each element in the reactant side has to balance the number of atoms that are present in the product side. So in other words, the total mass of the products formed in a chemical reaction is equal to the total mass of the reactants participated in a chemical reaction. It's kind of similar to math now. So do you remember RHS is equal to LHS, that is right hand side is equal to left hand side? It's the same here. In math, we prove that RHS is equal to LHS when both the values on the either side of this equal to are equal. So here also both the sides are equal. So RHS is equal to LHS. That is the total mass of the reactants. The beginning things that we use to form or start the reaction equals to the total mass of the products. So there is no mass that is going to be destroyed, or that is no mass that is going to be added during the reaction. And so now if we move forward and look at the balancing of chemical equation, what do we get by balancing a chemical equation? We get a balanced chemical equation. So what is this balanced chemical equation? The chemical equation in which the number of atoms of each element in the reactant side is equal to that of the product side is called nothing but a balanced equation, or basically balanced chemical equation. If you are more interested about balanced chemical equations, one more link is in the description. You can visit the website and find more about the topic. And the ones who are wondering, why isn't there an unbalanced chemical equation? So there is an unbalanced chemical equation too. It is just the opposite of the balanced chemical equation. So we can write it as the chemical equation in which the number of atoms of each element in the reactant side is not equal to that of the product side is called an unbalanced equation. So basically most of the equations are unbalanced. So we are going to learn how to balance the equations, and we are going to just balance them in few seconds. Okay, so now we have come to the steps for balancing chemical equations. So this part is really important. So concentrate more on this bit. And basically there are many methods to balance the chemical equations. But in our NCERT textbook, we have a simple method, that is the hit and trial method. So this might seem a little complex to you, but it's very simple. And I'm gonna say another very easy trick in which you can use it and solve the chemical equation, balance the chemical equation in just few seconds, and you'll find it very easy. So first of all, let's see how to do a balanced chemical equation using the hit and trial method step by step, as you should try it in the examinations too. So in here, let's consider the chemical reaction between magnesium and oxygen to understand the steps involved in balancing a chemical equation. The step 1. So let us first write the word equation for this reaction. So this would be magnesium plus oxygen turns to magnesium oxide. You might be knowing this. And the second step is to write the chemical equation for the reaction between magnesium and oxygen. So as we have written the word equation first, now let's try to write the chemical equations. After writing the word equations, it's as simple as it to write the chemical equations. So magnesium would be Mg, oxygen would be O2. So turns to magnesium oxide. So that would be M capital G and again O caps. Remember, the chemical equations are case sensitive. We must see very carefully that all the elements are written properly. Okay, so the third step is to count the number of times an element is occurring on both LHS and RHS in this equation. So we have to compare the left hand side and the right hand side of the equation. So in here we have Mg plus O2, which turns to MgO. So what do we have on the left side? We have Mg plus O2, whereas on the right side we have MgO. So we can write it in a tabular format like this: component, reactant, product. And then under component number 1 would be magnesium. So how many reactants are there? There are 2 reactants. It is oxygen and magnesium. So how many magnesium are there in the reactant side? We have only 1 because there is nothing written in the subscript. So reactant would be 1. And again, look at the product side. So in the product side, we have only 1 as well. So oxygen, on the reactant side, we have 2 oxygen. It was O2. So 2 number of oxygen. Whereas on the product side, we have only 1 oxygen. Therefore, this is an unbalanced equation, as you can see, because the RHS is not equal to LHS. there is one oxygen atom more on the reactant side, or we can rather say there is one oxygen atom less in the product side. So what do we do to equalize them? Let's see now. The step 4. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Choose a reactant or a product that has the maximum number of atoms in it. In that compound, select the element which has the maximum number of atoms. In this equation, we shall select MgO, that is magnesium oxide, and the element oxygen in it. So, to balance the oxygen atoms, let us multiply the magnesium oxide molecule by 2 on the right hand side. The equation can now be expressed as, so on the component side, again we'll make a table like that, component, reactant and product. Magnesium would be 1 into 2 on the reactant side, and on the product side it's 2. And again with oxygen, it is 1 into 2 on the reactant side and 2 in the product side. So now as you can see, they are quite balanced. But still we are not yet done. Let's move to the next step. Step 5. There are 2 oxygen atoms on either side of the equation, but 1 magnesium atom on the reactant side and 2 on the product side. Therefore, multiply the magnesium atom by 2 on the left hand side. Again, let's make the table. Component, reactant and product. Magnesium reactant and reactant 1 into 2 is equals to 2. On the product side again 2, and oxygen under the reactant 2 and product 2. So the balanced equation for this would be 2Mg plus O2 is equal to 2MgO. The number of atoms of each element of the reactants is equal to the number of atoms of each element of the products. So we have balanced this equation. But we have 2 more steps to do. Step 6. Writing specific conditions on the arrow, the reaction is carried out in the presence of heat. It represents this. On heating, magnesium combines with the oxygen present in the air to form magnesium oxide. So we can write it as you can see 2Mg plus O2 heat. Above the arrow we wrote heat. Then it turns to 2MgO. And the last step, step 7. Writing symbols of the physical state to make a chemical equation more informative. The physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of the reactants and products are represented by the notations G, L, S, AQ as I've said you before. So for this equation, we can write 2Mg in bracket S as Mg was solid plus oxygen which was gas. So G in presence of heat 2MgO which is finally solid. So we are completely done with the balancing of this chemical equation with the step number 7. So this was the hit and trial method that we have used. Okay, and as I've promised you for the shortcut for balancing of a chemical reaction, I would reveal it to you right now. So this is very simple and you can do those problems in just seconds by using this particular formula or the steps I'm saying you. So here also, let's do this by considering an example. We will take CaCO3 plus H3PO4 which takes to Ca3 in bracket PO4 taken twice plus H2CO3. So this would be our unbalanced equation. So let's see how do we balance this. First of all, as you can see here, write all these letters in front of these elements or compounds as you can see here. Use the variables A, B, C and D for you to make it more simpler. So before CaCO3 we would get A plus B H3PO4 turns to C Ca3PO4 taken twice plus D H2CO3. So we have basically set up a series of simultaneous equations, one for each element. So to solve this, we will now be using the conservation of mass application. So we would write it as Ca is equal to that is A is equal to 3C. So C would be A is equal to D and O would be 3A plus 4B is equal to 3C plus 3D, and H would be 3B is equal to 2D and B is equal to 2C. So as you can see, we have got the equations in 1 or 2 variables over here. And by considering the value of C as 1, then we would get out all of these variables values. So which would be very simple to solve this now. If we consider C is equal to 1, then A would be 3, D is equals to A, so it would be 3 again, B is equal to 2C, which is nothing but 2. So basically at last we would be A is equal to 3, B is equal to 2, C is equal to 1, D is equal to 3 by just simple calculations. And finally the balanced equation would be 3CaCO3 plus 2H3PO4, and after the reaction Ca3PO4 taken twice, 3H2 and CO3. Boom! Easy as that. So we have completed this very quickly, and you might be finding this more simpler than the hit and trial method, but in exam, if we get it for 5 marks, we should be doing all the steps and mentioning all the steps and do it in hit and trial method only. But like in MCQ questions or any competitive exams, you can directly use this. To know more about balancing of a chemical equation, there's a link in the description. You can go there and know more about it and explore the topic more. So that is it for now guys, and thanks a lot for watching this video, and please follow us on Discord, Twitter and Instagram. All the links will be available in the description too. So the next part will be coming very soon, so watch the second part too to complete the full chapter and get full marks in your examinations. Please don't forget to like, share and subscribe to the channel and click on the bell button to get all the notifications of the new videos after subscribing. Thank you once again. Bye.